Hey everyone, excuse me. Hey everyone, it's Mrs. Slauson. So this is a video for kind of like a pre-notes thing that we need to do in order to get through our section 4.3 in our chapter 4 note packet. So if you have a printer, great, maybe you've printed this up. If not, you can just write the problems as we go through. You don't need to write the whole problem, but I would write the equations at least. And so what we're doing is something called synthetic substitution. And what it's going to do is help us evaluate a number. So what you're used to when you evaluate a number is you plug the number into the function, you follow the order of operations, and then you get your answer. So I probably should have typed this up a little better, but the idea on problem 1 is we're going to determine if k equals 3 is a 0 of this polynomial, which means if I put 3 into k cubed minus 4k squared plus 3k, do I get 0? So what we're used to is putting that number in. And if you don't have what I consider a smart calculator, you would have to follow the order of operations to see if the left side is going to equal 0, which basically what the order of operation does is it takes the terms, which is those things that I'm underlining, it's what separates the addition and subtraction signs, and it gets it down to just a single number. So if I just kind of look at each term, I can do my own mini order of operations. So when I start with 3 cubed, what I can realize is that 3 cubed, 3 times 3 times 3, that this term becomes worth 27. When I go to the next term, I would do the exponent first and get 9, and 9 times 4 is 36. And when I go to the next underlined term, 3 times 3 is 9. And then if I just follow the order of operations and go from left to right, when I subtract these, I get negative 9. And then when I add that to the 9 that's above, I do get 0. So k equaling 3 is a 0 of the polynomial. In this section, I need to show you a different way to evaluate. And what I'm going to show you is called synthetic substitution. But it's also eventually going to get the nickname synthetic division. So the way I start is I make think of it as an upside down division box, and I'm going to take whatever I think the 0 is, which is k equals 3, and I put it on the left side as you're seeing, and then I'm going to go back to my function, and I'm going to re-highlight this in a different color now. And what I have to do is, if the highest exponent is 3, I need to make sure I have every exponent below that. So think of it as a countdown, the third power, the second power, the first power, to not having any k at all. But I'll need something there, so I put a placeholder in there, like plus 0. And then what I'm going to do is take the numbers in front, so I'm going to write this in the name box. If I were to put numbers in front of all the variables, and those numbers in front have a name of a coefficient, those numbers are what will go inside this division box, this upside down division box. So I have 1, -4, 3, and 0. And the way you do this is you bring the first number down, and that's a pretty common mistake, as people do not bring that first number down. And now I'm going to be doing some highlighting here and underlining and stuff. This 3 on the side is, I'll be using it a lot to multiply, and what I'm going to do is take my first number at the bottom, which is the 1, and I'm going to take 1 times 3, and that gives me 3, and I put it under the -4, and then I add this column of -4 and 3, which gives me -1. And now this -1 multiplies to the 3, and I wouldn't normally draw these loops. This is just so you can see what I'm talking about. And I get -3, and I would put it under the 3, and I would add this column, and I get 0. And then I would take 0 times 3, which is 0, add the last column, and get 0. And the number at the end should be the same number that I got here. And what we'll need then are these numbers that I'm about to box in for a later purpose, okay? So we're just going to practice answering the question, determining if what I give you is a 0 of the polynomial. And we're going to do it through this thing called synthetic substitution. So moving on to problem 2, I'm going to have my upside down division box. Since -3 is the number I want to see as a 0, it goes on the left side, and then I check my function. So if I start with the third power, I need every power below it, a second power, a first power, to just a plain number. And then all of those numbers, the coefficients, go inside the box. So in order, 2, 7, let me space that over a little more, 7, 1, and -8. And then I start by bringing the first number down, and then this -3 becomes the number I always multiply with. So again, I wouldn't normally draw these loops, but I will for the video. So 2 times -3 is -6, add those up, whoops, and I get a 1. 1 times -3 is -3, so I write that down, add this column up. -2 times -3 is 6, and when I add these up, I get -2. So in my first problem, determine if k equals 3 is a 0. The answer is yes, it is a 0 because I got 0 at the end. Determine if a equals -3 is a 0, then the answer is no. If I had actually put -3 in here and followed the order of operations, I actually would have gotten -2 as an answer. So if a equals -3, then let's say this was equaling y, right, which I didn't put in there, then y equals -2. And in order for it to be a 0, y has to be 0. So let's do one more, and then I'm going to have you practice the next set. All right, so I draw my upside down division box. I'll be putting -1, that's what I'm checking to see if it's a 0, and then I'm going to look at my list, and I got a third power, a second power, but what I'm noticing is I don't have an n to a first power, so if I rewrote it like this, I would just put a placeholder in, like that, and -2, and then the numbers in front are what will go in there, so 1, 1, 0, and -2. If you leave that 0 out, it won't work. So here we go. We're going to bring the first number down. Here's my multiplying number. 1 times -1 is -1. Add this column up, and I get 0. Multiply again. 0 and -1, that's 0. Add this column up, we get 0. 0 times -1 is -1. So when I'm done adding it up, I get -3. So is n equal -1 a 0? The answer would be no, because I get -3 at the end. So my answer is no, it's not a 0. What's happening is if n equals -1, and let's say again this equation was set equal to y, then y equals -3. And that's it. So as you go through the next set of problems, just double check that you have all your exponents like in a countdown. So I have a third power, a second, a first, and a constant. That's good to go. So if I were to set this one up, 3 would go here, and then inside the box would be 3, -6, -6, sorry about that, and -7, and I bring the first number down. If I look at number 5 and I check my countdown, I have a third, a second, a first, and just a plain number, so that one's good. So again, I'd put -6 here. Here goes 3, 10, -52, and -24. So again, you need to use this method because when we start the notes, these numbers will be also used. And you won't get those numbers if we evaluate the old-fashioned way like that. So that's it.